what's up, Diego? Are you just saying hi? Hi. Billy. Tiana. Sawyer. Olivia. Lily. Kyle. Okay, ladies and gentlemen, here we go. I'm going to finish taking attendance in a minute. I'm going to first make you guys a little bit smaller so I can see everything. And let's take a look at this warm up here. Okay? So we're looking at this warm up. That was a very quick thing today. Oh, if you guys want to, since you guys are already socially distanced, you can take them off if you want. Let's take a look at something that we noticed / wondered. So first, I need a couple friends at home. Please let me know in the chat. What did you copy and paste it? What did you say for something that you noticed / wonder? Go ahead, Caleb, and then Bridget.
I noticed how if you look at it, like the ladybugs form a diagonal line and the ants do too.
Okay, so they form diagonal lines. Good. I like it. That's a good thing to notice there.
I noticed, and I also noticed how like if they were like on a graph, like they would like like connect right into the middle.
Oh, so they would connect at some point. Okay, I like it. Okay, so I'm going to close that. So we would say they would so they're diagonal. So that sort of tells me that we're going to have like a similar slope. Okay, and then she said they will cross at some point. People at home, I need you to put stuff in the chat. Let's go. I need you guys to be active participants today. Bridget, go ahead.
Guys, if you look at the 6 seconds, you can't see the ants anymore.
Okay, so at 6 seconds, the ant is gone. Good. Okay, I need Gabby Campany to unmute and tell me one thing that you wonder. Let's go, Gabby. One thing that you know, one thing that you wonder.
I wonder how long it would take to get the ladybug to go completely across.
That's a very good question. How long, L-O-N-G, will it take ladybug to go all the way? Good question there. What else do we have as a question? Let's have, Avery says, why bugs? Question, Avery. I concur. I love it. I hate bugs. They're gross. Caleb.
I wonder how long it will take the ant and the ladybug to be at the exact same point at the exact same second.
I like it. How long will it take for them to meet? Okay, Bridget has one more. Go ahead.
Oh, why did they start on like different sides of the line?
Why did they start at different spots? Good question. Good. Okay. So one thing I want us to notice about these ants and these ladybugs. So last time we dealt with these ants and these ladybugs, they started at the same spot, but they had different rates of change, right? They were moving at different speeds. This time, they're moving at different rates of speeds, but they're actually, the most important piece here is that the ladybug is starting at the starting line, and the ant is starting at the finish line. So if we use that idea of the ladybug is starting at the starting line and the ant is starting at the finish line, they're walking where? Like if I'm walking with Bridget and we're reenacting this, are me and Bridget walking in the same direction, or are we walking towards each other?
Walking towards each other.
Very good, because when we're talking about this is the finish line, Bridget's starting at the starting line, we're walking towards each other because our distances are coming, they're converging to a spot. And then the ant actually goes past that. Good. That's the most important piece that I wanted you to pull out of this is that we're walking towards each other this time. So one of these guys might have a negative slope. I don't know. Okay? Okay, let's take a look at this next piece of this activity here. So we were just looking at what do we notice, what do we wonder. Now we're going to be dealing with some ants and ladybugs, some different ants and ladybugs, but they're going to be doing the same thing of like walking towards one another. Okay, so if we look at the graph on slide number 4, we're going to be talking about some ants and ladybugs that are walking towards each other, but this time they're going to be walking at a different pace than the guys before. Okay, so it says a different ant and ladybug start walking towards each other. The graph shows the ladybug's distance from its starting point over time, and the ladybug in the labeled point 2.5, 10 indicates, that's this guy right here, indicates when the ant and the ladybug pass each other. So where do they intersect? At this negative, or this 2.5, 10. Okay. It also tells us that the ant is walking 2 centimeters per second. Okay, so the ant is walking 2 centimeters per second, and they're going to meet at this 2.5, 10. So my first question, if we were to look at this ladybug and we wanted to create an equation for this ladybug, we would write it in the form of y equals mx plus b, where m represents our rate of change, or that fancy math word we use for that is our what? Our rate of change, our slope. Very good. Very good. Yes, Jaden Ramos. Our CROC, our constant rate of change. Very good. Our slope, or our CR, that's an R, OC. Constant rate of change. Good. And that B represents our what? Our Y intercept. Very good. The B represents our Y intercept. Where does it hit our Y axis? Okay. So if we want to look at first the equation for this ladybug, let's think about how we could write the equation for this ladybug. The ladybug is going to start with y equals. You don't have to, if you have paper, you can write this down. People at home, you don't need to necessarily type this in anywhere. We need to figure out our slope, or our rate of change for our ladybug. And when we have a graph here, how do we calculate our slope on a graph?
You draw a slope triangle.
We have to draw a slope triangle. So my suggestion, instead of going over like one box, I would go over till you hit 1 and then connect it up. And we're going to look at that. So our run is how much?
2.
It's 2 boxes, but that represents how much? 1. 1 second. Every 1 second, how far does she go? 4 centimeters. So my rate of change, if we're going rise over run, would be what over what?
4 over 1.
4 over 1. Very good. So the ladybug would be 4 over 1x plus my y-intercept. Where does it hit the y-intercept? The y-axis, I mean, I'm sorry. Where does it hit the y-axis?
0, 0.
It hits at 0, right? So it hits at 0, very good. The origin, so it would be 4 over 1x plus 0. Okay, that would be the ladybug's equation. Now, we don't have the ants line drawn in, so we need to actually draw some points from our ants line. Okay, so if we look at this, we know he goes what's his rate of change here? How fast is he going every second? Or how far is he going every second? I'm sorry.
2 centimeters per second.
2 centimeters per second. So that means his rise. So if we were to write it as a slope, it would be 2 over 1, right? It would be a slope of 2/1. Very good, Jaden Ramos. But he's moving towards the ladybug. So he's going, his line in general is going this way. So what kind of 2/1 is that going to be if it's getting smaller?
-2/1.
Very good, because when our line is going down, very good, Avery, very good, Jaden, very good. As we move left to right, if it's going down, it's going to be a -2/1. Very good. So we know that this point, this 2.5 comma 10 is going to fall on that line. So if I take this point, I can extend it my rate of change, right? So if I were to, I would rise how many?
Rise to.
It's,
-2.
and it's -2. So we're going to go down 2
Yeah.
and over how far?
1.
1. How many boxes is equal to 1 second though?
2 boxes.
2 boxes. So I'm going to have another point that falls here. Let me do that with another color. Friends at home, let me show you how you're going to do that. Okay, so don't freak out. So you are going to draw that point on there by going like this. You're going to grab this off of this pile right here. 1 second. You're going to come over with this guy right here. You're going to go down your 2 centimeters over your 1 second, and you're going to drop that point down like that. Okay? And then we need to draw a line in. So let me show you how you're going to do that. First of all, my friends, in school, do we have rulers still in our undercarriages?
Yeah.
So do you still have your place? Yeah. Okay, perfect. So we have this point right here. We have this point right here. At home, if you're at home, my friends, you're going to click on the line tool up top. And you're going to put your cursor right on that 2.5 comma 10. Connect it out to here. And then now you're going to just extend it up that way.
So just make an X.
Yeah, so it's going to look like an X, but it's not going to be like a perfect X. And then I like to change my color so I can see it a little bit better. And then make it a little bit thicker. Like I did like 3. So your line should now look like this. I'm so sorry about that, Diego. I'm so sorry. That's upsetting. I wish you were here. Okay. So I just was able to do this, and I'm really proud of myself. So we just created an equation line because we took that point that we knew fell on the line, this guy right here, and we extended it, our rise and our run. Our rise was -2, so we went down 2, ran it over 1 second, which was 2 boxes, and there we go. Okay, so now I need to write an equation for this line. Let's think back to how we did it for our ladybug. Let's think back to, in general, how we write an equation. What do we have to start with when we're writing this equation for the ant here? You know, when we start an equation, we always start with what equals.
Y equals the slope.
Very good. Y equals. Very good, Gina Ramos. Very good. Avery, very good. Bridget and Alyssa Button. Very good. Y equals. Nice job, Avery. And then we have to talk about our M, right? Which is our rate of change. What did we say our rate of change was for this ant here?
-2/1x.
Very good. -2/1x. And when you type it in, if you want to write it as just like Jaden did, 2/1, like that, that works as well. 2/1x. And then we add in our what? Plus our b, which is our
Y-intercept.
y-intercept.
So wouldn't it be 15? Because that's where it meets the.
Keep going.
That's where it meets
The
Y-intercept.
the y-axis, right? So we would say that our intercept is going to be 15 because when we trace our line to where it hits our y-axis, it hits at 15. Positive 15. Nice job.
I have a question.
Okay, Jacob.
So I'm trying to write the equation,
Yep.
but you know how usually when you write 2/1, it automatically does it. So I put a space and it didn't do it. So do I just leave 2/1?
Yes, so the reason that it didn't do it is because you wrote it as 2/1 instead of 1/2. When you do it as 1/2, it usually converts it into a fraction. But because we're looking at just the number 2, if it just looks like this right here, Diego, it's okay.
Uh-huh.
Does that make
Okay.
sense, Diego?
Yeah.
Perfect. Let me know if you have any questions, buddy. Go ahead,
Am I
Osman.
gonna go to the bathroom or should I?
Yeah, no, go ahead. Very good. So we just wrote that equation based off of this idea of y equals mx plus b, y equals our slope times x plus our y-intercept. Good. I'm going to keep that up for another second. And I think I'm actually going to leave this piece up here because I think we're going to use it next slide anyways. Okay, so what I'm going to do right now is I'm going to copy this guide here. We're going to look at slide number 5. And so with the slide number 5, I want my friends that are at school and my friends that are at home, you don't need to recreate this graph on the next slide. What I'm going to do is you don't have to, let me show you one second. Snipping tool. New, I'm going to go like this. And I'm going to go copy. No. I don't need to save it because it's already here. So when we come on to slide number 5, you're going to see that there's another blank grid here, and it asks you to graph it. I don't want you to graph it again because that's crazy. So what I'm going to do is I'm going to paste my image over here, and you're just going to answer that second question that's on here. It says, let me just go like this. It says, what do you notice about this graph? So I want you to take 1 minute right now to write down 2 to 3 things that you notice about this graph. Anything at all that you notice about this graph. Take 2 minutes right now to give me 2 or 3 things.
Do I have? Okay. Do I have to put the other line too? Because I see you have the line on.
No, so I just copied and pasted my picture. Yours can look like this, it can be blank. I just want you to use this picture that I put here and just write down 2 things that you notice.
Okay.
Yeah, so you can just write them in that general area if you like. If it doesn't fit in the box, that's okay. You can write it like here, you can write it there, anything you notice. Okay. Taking another minute and a half. Oh, Michigan is really confused. Your schedule is really confusing, guys. Okay, still have time. Good. Nice. Oh, wait. Okay, so yes, yes, Avery, that's a good point, and I'll talk about that when we come back together in a minute. Okay, I'm going to talk about why they mean the same thing. Okay, 1 second. Let me just wait 1 more second. What's that KDB? Coordinates for Danny. Lee is not here. Jaden is here. And Avery's here. Perfect. Okay, so let's take a look at these ideas that we were noticing about this here. Okay, So first thing, Avery, I want to just bring up this one thing that Avery said. So Avery said that it's not negative. So we wrote our equation as y equals -2/1x plus 15. And I want to point something out to you. Is that when we write it like this, with this -2/1, it means the same thing as writing it as just -2. Okay, so you can say that they're written differently, and that's a good thing to notice. But I want you to know that when we write it differently, when we write it as a fraction over 1, a number over 1, it means the same thing as just saying that number, that numerator number. The reason I wrote it as a fraction is because you guys know that slope is usually written as rise over run. So I wrote it as a fraction so that you don't forget about that run number. Because when you look at just 2.5, like for example, just the number 2.5, you might say my rise and my run is 2.5, but it's really 2.5 over 1 with a rise of 2.5 and a run of 1 to the right. So the reason I wrote it as a fraction over a number over 1, it means the same thing. I just wrote it so that we remembered rise and run. Good thing, nice job. What else do we notice?
I was just gonna ask if we draw the line on it again.
No, you don't need to draw the line again. Okay, what else did we notice here? What did you notice?
I said the ant's line is going down.
Let's see, Sawyer, can you unmute? What did you notice? Anything that you notice here?
How about the graph?
Anything at all? Yes.
It makes like an X shape.
Very good. What's the button?
The ladybug's line starts at 0, 0, and the ants goes there.
Miss, I don't know if you're not talking or is like the audio's just going out. I don't know.
Oh, no, I wasn't talking. I was writing down what Alyssa Button said. Alyssa Button said, I was going to read it at the end. Alyssa Button said the ants, the ladybug starts at 0, 0, and the ant does not. It starts at 0, 15. Good. Let's see. Can I have Isabella? Can you unmute and can you tell me something that you noticed? What did you notice, Isabella?
The lines intersect.
Boom! I love it. Great thing to say. Lines intersect. Awesome job on that, Isabella. I love it. Kaylee B, what did you notice?
I noticed that, I don't know if I'm 100%
Go ahead.
sure about this, but that the ladybug's line goes through the 0, 0, so it would be a proportional relationship.
Okay, Kaylee B just said something so amazing, and I love it. Kaylee B said that the ladybug shows a proportional relationship because it goes through 0, 0. Yes! Woo! Kaylee B, you're
Okay, Miss Jermaine.
I'm very excited. Ladybug equals proportional because it goes through 0, 0. Yes! Woohoo! Love it. I love it. Okay, very good. What about the ants line? Would you call him proportional?
Not proportional. It's a non-
Do I gotta write all that like in the box?
You would write a couple of them, yes. You need to write at least 3 or 4 down. Very good. Our ant, awkward. Ant is not proportional. Very good, because he starts at 0, 15. Awesome. Anything else that people noticed about this? Oh, anything else that people noticed about this line here? Go ahead, Bridge.
I said that there's 2 points on the ant's line.
There's 2 what?
There's like 2 points on the ant's line.
Good. I like it. We have 2 points on our ants line. Ants line. has 2 points. How many points does the ladybug's line have?
It only has one.
It only has 1. Very good. Because this point where they intersect is on the ladybug's line as well. Very good. Probably the most important piece of this whole activity is that when we have 2 equation lines here and they crisscross, those points are on both of those lines. Nice job there, Bridget. Very good thing to notice. Anything else people are thinking? No? Okay, perfect. So here's the dealio. We're not going to get through the whole next activity. I know that. We're going to get through as much as we can. Okay, I'm going to move you guys over here. I'm going to scoochie forward. And we're going to look at this piece here. Okay, so this piece here, we're going to be doing 2 things here. First, we're going to be graphing some lines given different information. And then we are going to be writing equations based on those lines that we make here. Okay. So if we look at this first piece here, it says a line goes through point 2, 5 and has a slope of 1.5. First question I'm going to ask myself, if I were to write 1.5, the slope of 1.5 as a fraction, it would be 1.5 over what?
1.
Very good, because I like to write, when I'm given a whole number for a slope, I like to write it as a fraction over 1 because I don't want to forget that run of 1. So it's going to be a rise of a 1.5 over 1. That's my first piece because I personally think it's a little bit easier to look at it this way. Okay, so it says it goes to the point 2, 5. So on this grid, what can I do?
You can,
Oh, it's fine.
You could do a run of 2 and a rise of 5.
Very good. Our slope is 1.5, 1. So we're going to run it. Once we get to this point here, we can do this rise and this run. But first we have to put a point down at 2, 5.
Mr. Mean,
Yeah, go ahead, Diego.
why do you say 1.5, 1? It only says 1.5.
Because all whole numbers like 1.5 can be written as a fraction of 1.5 or the number over 1. And I like to write it as a fraction over 1 because slope is rise over run. And I don't want you to forget to do this run piece here. Okay? We'll talk about it in 1 second. I will show you what I mean by that, okay? So I need to put a point. It goes through this point of 2, 5. So that means I need to take one of these points off the pile. And how do I get to 2, 5?
make a run of 2.
Very good. A run of 2 and a?
Rise of 5.
Very good. So I come onto my grid here and I'm going to put a point down at 2, 5. Okay. And friends at home, you're going to need to click on the graph, right click it, hit order, hit back, send back. Okay, I'm going to show you again. So if your point doesn't show up, you're going to right click, order, send to back. I can't click because it's already all the way back. Okay, so I have this.
Hey, what?
Oh, go ahead, Diego.
Right click what?
Right click and then click on order. And you see this right here, order, and then go down to send to back.
Oh, there it is. Okay.
Okay, so we have this point on our grid here. And I need to extend this line using this slope. So that means from this point of 2, 5, what am I going to do if I want to rise and run it? Jaden Ramos, what am I going to do if I want to extend this line? I'm going to rise it how many? What do you think, Jaden Ramos? So I'm going to come to this point and I'm going to do what? Alyssa, oh, I'm gonna run it, but think about, this is our slope here. Our slope is 1.5. So Alyssa Button, what am I gonna do?
You're gonna rise it up
1.5 boxes. Very good. And then we're gonna run it to the right, how many? 1. Very good. And I'm gonna drop it. And I'm gonna have a point right there. And now those are 2 points that fall on the same line. So what can I do with those 2 points? Connect them. Very good. So you're going to grab one of these lines off of the pile here. And what I like to do is I like to line it up with the second point so I can bring it down to my axis. So you line it up with that point on 3,6.5. And then you grab the end of it and swing it down. And just extend it out until it hits your Y axis. Okay? So if we think about writing the equation for this line, we think about it in terms of y equals mx plus b, where m represents our slope or our rate of change, just like Jaden always tells us, our slope or our constant rate of change. Very good. And our b represents our y-intercept. Very good. Very good. So if we look at this guy here, if we want to write the equation for this line, y equals m. What's our m or our slope? 1.5. Very good. You can write it as 1.5, or you can write it as a fraction of 1.5 over 1. And what do we attach to our slope? What letter? X. Very good. 1.5x. And then we need to add in. So Avery, what you need to do, I said this at least 3 times. You need to come over to your graph. You need to right click, hit order, send to back, because then you'll be able to see it, okay? Okay, so plus, where does it hit my y-axis, my y-intercept? What is it? 2. Very good. I extend my line backwards. Where does it hit my y-axis? At that number 2 plus 2. Okay? And now, this next piece here, I'm going to erase this just so we can see it a little bit better. It says a second line goes through the point 2, 5 as well. And it has a y-intercept of 0, 10. So I don't need to put another point on my line here for that 2, 5 because we already have that point on there. But I need to plot my y-intercept. So I'm going to take this point, and what am I going to do to get to that y-intercept?
You're going to go from 0, 10.
I'm going to come up to 0, 10, and I'm going to put a point. And then now that I know that this is my y-intercept, I can do what with these 2 points here? Connect them. Very good. So you're going to, if you're at home, you're going to grab one of these lines, line it up with your intercept here. Grab the end of it, pull it so that it goes through this 2, 5 here. Boom.
Kyle's internet crashed and he might not be back. So just letting you know.
That's okay. Thank you for
RIP Kyle's internet.
Thank you, Sawyer. I have the recording, so I'll send it to him later, okay? If we're trying to write the equation for this line now, okay, you can still be working. Let's listen. We are going to use this idea of y equals mx plus b. Do we know what our m or our slope is?
No.
We're going to have to do what to find it? Exactly. We're going to have to draw a slope triangle. So I'm going to come in with my pen here. I'm going to say, I know that it hits here, and I know that it hits here. Because like this spot right here is like not perfect. So I'm not going to pick this point right here because it doesn't hit, like it's in between and I don't know the exact number. So we know that it hits perfectly at 0, 10. We know that it hits perfectly at 2, 5. So if I write it as a fraction of my rise over my run, what's my run going to be? 2. Now, I don't want you to shout out the rise automatically. I want you to think. What is our rise going to be here? How many? So we're going Which way? Which direction?
Going down.
We're going down. How many? What was the button?
5.
-5. Very good. So our equation would be y equals -5 halves x plus, where does it hit our y-axis? Just give me like 3 seconds.
Yeah.
Yes, Kaylee B, plus 10. Okay? So ladies and gentlemen, tonight for homework, you have 10 minutes on Alex. You don't have to do anything with these slides. They can get turned in. Your homework for this evening